Hey everybody, Brian Beeler here, and welcome to the Storage View podcast. Today we're getting way ahead of the curve. We've done, I think, 3 or 4 podcasts in the last 6 months on PCIe Gen 5 and what that gets us, and the storage that's coming, and the interconnects, and all the benefits of Gen 5. And wouldn't you know it, PCI-SIG has already been ratified and is out there. Now, it's not out there in a consumable way just yet, but we can talk about the logistics of what PCIe Gen 6 is, and we've got a very special guest, the guy that knows probably more than anybody else about this thing, Al Yanis with IBM. Al, thanks for coming in with us today. Thank you.
Thanks, Brian. Thanks for having me.
I could feel you probably cringing as I called it Gen 6 the whole time, because I know you guys like to be real formal at the PCIe-SIG. So are you okay with Gen 6, or would you really prefer it be called PCI-6?
We say PCIe 6.0.
Okay. So don't call it Gen 6?
We won't kill you.
Well, I don't know what it is, but like in our world, at least on the publishing side, you guys deal with the technicals, then we get these things in, and it's a Gen 4 SSD, it's a Gen 5 SSD, whatever. It just seems, for whatever reason, easier to communicate it that way.
Yeah, it's no big deal.
All right. So you've been with IBM for almost forever, and you've been working with the PCIe-SIG for a long time. What's going on there? What do you like about either one of those things, or give us a little bit more background too on your interest in this field?
Well, really started with PCI. So we're going to have our 30th anniversary this year. So PCI started in 1992 or thereabouts, and I started working on PCI, and then PCIe came along. So from an I/O perspective, which is where I've been focusing on most of my time at IBM, PCI and then the subsequent PCIe has been the I/O bus standard, that everyone uses. So it's been a great experience, being part of the technical, and then now I'm part of the board, mostly focusing on doing my role as president and chairman of the board.
Well, take us through some of those early days, because that had to have been pretty wild back then. I mean, it's funny, we think about SSDs today and how many vendors there are and that sort of thing, but back in the old days there were that many hard drive guys running around. I mean, technology was way different in the I sound like an old guy, not that long ago kind of world, but just what did things look like in the early 90s when you were getting involved in this?
Well, there wasn't a standard, right? So that's why PCI was such a play, because everybody did their own proprietary interfaces. We had the AGP for the graphics, and we had PCI eventually for the I/O, and everybody slowly migrated to PCI. Right, we started with 32-bit, 30 megahertz, and here we are, right, running 128 gigabytes per second in one direction, 256 gigabytes of total bandwidth with our recent announcement. So yeah, it's a sign of what we've accomplished as an organization, but also what the industry has sort of evolved through. We got some charts that show that the I/O bandwidth has doubled over the last 30 years, almost every 3 years. Mm-hmm. So almost like a rule of thumb. So yeah, there's been some times like between PCIe 4.0 and 5.0 where it took us about 7 years, but the cadence has been like a doubling of I/O bandwidth every 3 years for the last 30 or so years. So great for our members, and great for our work group and what we've accomplished. And people come into the work group, people leave the work group, but the organization has been steady and doing very well. Recently we hit 900 member companies, which is one of our highs for the last 12 years. So things are really looking good for our organization.
So speaking of the organization, how do you work with other standards groups? I mean, NVMe would be an obvious
sure.
Good fit for PCIe. I mean, it's the storage interface du jour, right? So how does that work amongst the groups?
We usually have some joint disclosure agreements where we establish a exchange of information or joint publications or joint publicity or touting each other's technologies. But a lot of the folks in the NVMe, for example, versus PCI-SIG are similar, or the companies are similar.
Hmm.
So we're all in it together to have a successful product. So there's a lot of good exchange of information between members that are in both organizations. So if they need something, through the members, the common members, that information gets propagated to our work groups.
Okay, well, you talked a little bit about your calendar of roughly doubling every 3 years, and it's interesting, I think, as we look at the end shipping product, whether it's a PC or a server or whatever it is that uses the standard, it seemed to be that the gap from Gen 3 to 4 took some period of time that didn't feel long. It was just time, right? It was a reasonable period of time. But from 4 to 5 has been almost overnight in terms of the acceptance and growth. I mean, on the client side, the last generation boards have had PCIe 5 lanes built in. We've got now Alder Lake CPUs that'll support that and pump out a limited amount of Gen 5 across the board. The server guys will be a little bit behind that or different in their adoption of it, but we saw Samsung's got SSDs now that we've been able to do some light testing on that are PCIe Gen 5. So it feels like the consumable version of what you guys are doing on the standards side of it has been pretty quick from 4 to 5, despite there being maybe a little bit longer lag in the spec. How do you sort of reconcile that, what happens on the spec and then what eventually ends up shipping either to consumers or the enterprise?
Yeah, I mean, you make a good point, right? There was a lag, and so now it's kind of like it all averages out, if you will. Our rule of thumb, Brian, has been 12 to 18 months after the specification is released that we'll see products. So I think that rule of thumb will continue. There's going to be folks that are going to demo early and show their ability to do 6.0 rates. But in general, the rule of thumb has been 12 to 18 months. But we're in the standards organization, so that's a business decision. Each company will go through the return on investment of adopting a new technology, because obviously PCIe 6.0 won't be for everybody. There's some cost plays where if you had a by 4 PCIe 4.0 solution, you can get the same data rate with a by 1 PCIe 6.0. So there's some opportunities for costs, but the primary usage would be higher bandwidth, obviously with the PCIe 6.0. But you need to have better motherboard technology. There's costs associated with the higher bandwidth. So not everybody's going to migrate to it immediately, and not everybody's going to see the business opportunity there. But hopefully, we're anticipating a lot of the FPGA accelerators, eventually storage, the HPC market. So there's going to be a lot of folks, the 800 gigabit Ethernet. So there's going to be a lot of folks moving or needing that higher bandwidth. And from a standards organization, we always want to be ahead of the curve, ahead of what the industry needs, so our members can plan their roadmaps, can plan their product intercept cycles, and so forth. So yeah, we're excited about this recent announcement because it really took 2.5 years from PCIe 5.0 to get to PCIe 6.0. So it's a good cadence that we're on.
So talk a little bit about what that means. So as we go from 3 to 4 now, and when we think about SSDs, for instance, let's just work there because that's where we're really familiar. Basically, a doubling of bandwidth, and now things that were 3,500 megabytes a second or whatever are now close to 7,000 on reads and really fast. And now we're seeing 14 gigabytes per second out of these Samsung SSDs that are Gen 5 in straight read. So again, another progressive doubling. And to your point of yes, but not for everyone. A thin and light value PC probably doesn't need a bunch of Gen 5 or 6 lanes in it
Correct.
because it just won't make sense from the investment standpoint. HPC, though, obviously a big jump, maybe high-end workstation, professionals, gamers, maybe something there. A lot of potential, but now it's introducing some design decisions where it doesn't seem like that was necessarily the case from 2 to 3 and 3 to 4, or am I just ignoring the past history?
Well, you're right, and we have another cute chart that we listed the 30 permutations, right? Because we got 6 different speed options, and we have 5 different sort of width or feeds, is what I call them, options, because we have by 1, by 2, by 4, by 8, and by 16. So we have 30 different permutations that end up being 10 unique bandwidth profiles. And it gives everybody some options. Let's say some of the storage folks want to only run by 1 because it reduces their routing, because it reduces their cost, or reduces their cabling. So PCIe 6.0 will allow you to go by 1 and still double your bandwidth if you were in a PCIe 4.0 solution. So just a lot of different options that you have now. So it's up to the members to decide, and with the business opportunity of where they want to be. But yeah, we got 5 more options, right? And we used to have 25 with the PCIe 5.0. So it's pretty cool. They're all backward compatible. So our recipe of success has always been backward compatibility. So you can plug in a PCIe 5.0 add-in card to a PCIe 6.0 motherboard, and it would work. And vice versa, you can plug in a PCIe 6.0 add-in card into a PCIe 5.0 motherboard, and it'll be compatible. So these mix and match of different bandwidth profiles just gives everybody an opportunity to what do you need, and when do you want it. So it's pretty cool.
Yeah, so talk a little bit about the implications for server design then. You started to hit on lanes for storage, and that's something that, I mean, you've got Intel boxes, AMD, ARM, whoever, they all have this issue with either lane affinity to the CPUs, which is something that's become more interesting as things have gotten faster. There's where do you send the lanes? Do you send them all to the front for SSDs? And if you do that, what happens to your back-end connectivity? You call them businesses decisions, and really, that's accurate. But there's a lot of design decisions that go into this. In the current designs, what does Gen 6 do that's fundamentally different? I guess how do we think about, aside from speed and some 5 new profiles, what else comes to the table? What can come to the table from system design standpoint?
Yeah, we've added some power friendly because everybody's always interested in reducing their power. So we have some more capabilities on the power side, where if you're not using all the lanes, let's say you have a by 8 solution and we don't need all the, at certain points in time, you don't need all the bandwidth of a by 8. You can sort of run this mode where you dictate how much power you can consume for that link. So there's some more power friendly options. So the protocol layer has always, sort of evolved based on everybody's needs. So, that's all in place. But for PCIe 6.0, some of the sort of the infrastructure that was put in place was we changed from NRZ to PAM4. So our signaling now is a PAM4 signaling. So this is a capability that's been out in the industry, and so we've leveraged what some of the industry previous serial and deserializers designs have been, which is PAM4. So early on, we made a decision to go to PAM4 instead of NRZ. So that's a little bit of a change from what we've done previously, which was all the previous generations were NRZ on the PCIe. We've also went to a FLIT mode, which is a flow control unit, which is we always send now 256 bytes of data. And what that allows us to do is we're a little bit more efficient on the encoding, because we switch from the 128-bit 130-bit encoding that we introduced in PCIe 3.0. So that's another change that we've seen as an advantage. And then with PAM4, there's this thing about forward error corrector code, where you want to make sure that you have a fast enough latency. So we've come up with a three-way forward error corrector code that improves our latency through the PAM4 signaling. So that helps us with our latency. And then for the bit error rate, which was also another challenge, we went to a 32-byte CRC to make sure that we detect any bit error rate fails. And we leveraged our replay buffer to allowed us to maintain the required high bit error rate that the spec sort of expects and demands.
Interesting. So does that do anything from an efficiency standpoint for applications or storage or even GPUs or FPGAs in terms of how they want to interact with each other, or how the application wants to interact in terms of things like block size? Does anything change there or matter in the new spec?
Well, it just made things a lot easier for us, and made things a little bit more efficient to always do a fixed packet. So depending on your workload, there's going to be some pluses or minuses. So it really depends on how big of the data and how much data you're sending. So typically the higher packets will be more efficient versus the smaller packets because of the fixed 256 byte of data that we're always transmitting. We're always transmitting 236 bytes of payload and then 20 bytes of the extra information of the header information, if you will.
So does that mean that applications or the end devices themselves will need to be more efficient to coalesce their requests?
Yeah, the core, the PCIe core now, you got to support the old mode, the legacy mode, and you have to support the new mode. So yeah, we're keeping these PCI Express core designers fully busy because it is a bit of a challenge to support the different differences now associated with PCIe 6.0.
So with every generation, you mentioned some of the opportunities that are there from a performance standpoint. You talked about interconnect and a little bit about storage. Let's get some of the hero numbers out there. What does this let you do from interconnect, and what does it let you do in terms of what you think max transfer rates are, or something else that people can get excited about from a practical standpoint?
Well, you kind of hinted at it, Brian. It's we're pretty simple engineers. We just doubled everything. So
you just write ×2 in the coding, then you're done?
I mean, you said it was, what were some of the numbers you were saying, 14 gigabytes? So 14, if your number was 14, well, now you can go to 28. So whatever you had before on 5.0, you're essentially going to be able to double. So you can never say, well, the PCI Express is not fast enough, right? If you're in the storage business, because we're plenty fast. And if you were already in a PCIe 4.0 solution and you want to leapfrog from 5.0 to 6.0, you can quadruple. So
yeah, from 4 to 6, right?
Yeah, from 4 to 6. So it's, if you haven't made the jump to 5.0 and you got a 4.0 solution, you can theoretically quadruple. So puts us in a good spot, right? Because we never want to be the bottleneck. You never want to hear somebody doing in the lab doing the performance analysis, oh, the PCI Express is not fast enough. Oh, if only the PCI Express was fast enough, right. I would hit my bandwidth numbers.
Well, you're only getting that on like large block reads anyway from a storage perspective, which isn't a super common workload, but it is the hero workload.
Yes.
To be able to prove that you can max the interface, right?
Yeah, and so you're going to definitely you can do all your hero, as you call it, hero bandwidth numbers now with 6.0 because you can theoretically prove that your infrastructure can support 28 gig or whatever the number is. Yeah, from a by 16 solution, the one that we tout, which is the by 16, we have with 6.0 256 gigabytes per second. PCI Express, as you know, is full duplex, so we can send 128 gigabytes per second and receive 128 gigabytes per second. So we just to give you the total number, in our chart and say it's 256 gigabytes per second of total bandwidth with a PCIe 6.0 by 16 solution.
I mean, just the back end I/O that'll enable for servers may cause some interesting design decisions too, right? Because now that when we think about some of these high performance storage solutions, whether it's an array or it's some NVMe over Fabrics thing or whatever, then we've got to kind of multiply out how many ports does that need and how many client systems do we need to be able to maximize that storage. Sure. And a lot of that's, even on a 100 or 200 gig card, I mean, there's just still some math that takes place there. So what can your thing do? And then how many systems do you need to drive that total bandwidth? With that kind of I/O, although if storage gets faster, it'll be an interesting balancing act to see what that means.
And there's the port counts. Sometimes, the CPU will have a limited amount of ports, obviously, right? There's not infinite amount of physical wires. So you can always go, you maintain your by 8 link, and now if you doubled it, and you can go to a switch, and then you can go, and attach some of the lower bandwidth, a lot of by 1s or by 2 solutions to that by 8. So it just gives you a lot of flexibility, and it allows folks that are I/O bound or number of I/O pins bound, gives you the ability to still potentially hit your bandwidth numbers with your limited number of I/Os, because now you can go twice as fast.
So to the extent that you can, I mean, your spec is one thing, but then there's CPU design, motherboard design, then peripherals to support the thing. So forgetting the storage and cards for the moment, because they'll figure that out probably more quickly because they're least reliant perhaps on some of these other design decisions. Let's talk about CPUs. What do Intel, AMD, ARM, Apple, whoever else, what do they have to do to be able to support PCIe 6 spec? What fundamentally changes for them?
Well, the biggest changes are the PHYs, right? Because those are the ones that are going to see the differences between NRZ and PAM4. So the analog portion and the electrical portion of these high-speed protocols now has become really the key element to enablement, where you can handle the different bandwidths because you're still got to support the legacy frequencies. You're going to have a short card, short route or a long route. The channel is going to be a range of different channels. Your equalization parameters. That sophistication is key, right? The ability to, especially in our protocol, to run the different speeds in the different generations, and now PAM4 versus NRZ. It's very complicated, and that's why there's only several folks that do PHY designs in the industry now, and they're very good at it, and that's the key in my mind of making sure that you're compatible with all the different the range of channels and range of specifications.
Yeah, that's interesting. And then on the motherboard side, it's more just the physical layout of how this comes together, right?
Physical layout, what kind of motherboard technology you're going to use, because Megtron and what kind of Megtron, how you're going to do your routing. The connectors are more sophisticated. The connector technology has evolved very, very well over the last 10, 15 years. We used to say, oh, if you go on a cable, that's going to make it worse. Well, now sometimes the cable has better loss material than the motherboard, and some cable solutions can go faster than motherboard technologies. So it's interesting decisions, and you sort of got to know what you're doing to be able to achieve these high bandwidth. You have to be precise.
Well, that'll be interesting to see if there's a little bit of a spread between who does it really well and gets full performance and who's just not quite there in terms of overall system design.
Just yesterday we had our one of our compliance data gathered. Last week some of our compliance, because that's another recipe of our success, Brian, is our compliance workshops, where we facilitate our members for free to come and plug and play and run their motherboard or add-in card solutions to a de facto standard to make sure that everybody's developing everything, correctly, and we have, everybody pointing in the right direction. So just last week they had their 5.0 solution, or 5.0 data gathering, to hopefully enable our 5.0 integrators list later this year. So one of our successes is also this, compliance events that we hold throughout the years. Coronavirus has impacted a little bit of some of that. We had to do some virtual events, but the team has been able to figure out even how to do virtual events where you send your cards. But that's another part of our recipe of success, is this constant monitoring of, compliance events and workshops to facilitate that everybody's, doing it, designing it correctly.
Yeah, well, it certainly helps to have those progressive checkpoints, right?
Yeah.
Where what do you call them, plug fest? Or I know that's the
Exactly.
terminology in some of the other
That
things.
is
Right?
the good term. That's the terminology, plug fest.
So with this move to the 6.0 spec and the faster performance available through the whole ecosystem, one of the things that we're hearing concerns about is heat. So these things are faster, more power. Some of these multi-lane cards are talking about sucking down like an E3S SSD, 4 lanes, 70 watts at the front of this thing, times 24 across the front. I mean, it's a tremendous amount of heat to dissipate. You sort of glanced on connectors before, and I want to kind of revisit that as part of this heat conversation, because so much heat gets expressed through that connection point. What do you think about that in general? Is that within the bounds of your working group to figure out? Is that not? Like, how far do you go down that road?
Yeah, that's a good question. And yeah, power and heat is always an important element. It's something that we try to do better at. And like I mentioned, that we have the sort of more power friendly options with 6.0, where you can sort of target a lower power so you don't have to use all the lanes.
Mm-hmm.
The one thing that we've noticed is less lanes. So let's say you have a by 4.0 solution, and you compare that with a by 2 5.0 solution, both running the same data rate. Traditionally, the by 2 will run better power wise because it has less, the physical lanes, even though they're running faster. So hopefully the 6.0 solutions will facilitate some more of that, or maybe you have the same link, or half the width to achieve your bandwidth, and consequently help with your power. But the laws of physics are the laws of physics, and there's only so much we can do. But I know it's a challenge, and we're open to new ideas. And one of the things we came up with when we got into the handheld space, right? Because PCI Express was never, and then originally power friendly, was we came up with the L0S, or the standby power mode,
Mm-hmm.
and that allowed us to completely go idle on the interface, and consequently this allowed us to go to zero power usage when we didn't need to. So we do have some options for power friendly, but sometimes they require a wake, or you have to wake up the device and so forth. But those options are there to be more power friendly. But yeah, we're open to suggestions and ideas on anything we can do to be more power friendly.
Well, it seems like liquid cooling might come help save part of the day, at
I've seen
least
some
in.
of those.
Yeah, well, I mean, we were just at Supercompute in St. Louis, 2 or 3 months ago now, and if you weren't looking at a water cooled booth of some sort every other time, I mean, I don't know how. It was either connectors or tubing or complete systems, and this ranges from everything from high-end workstation or gaming rigs where water cooling is very common, especially for the CPUs and now even DRAM and GPUs. But all the HPC systems, I mean, Lenovo was showing some amazing stuff, Supermicro, all of these solutions where they're trying to get the heat off the CPUs, but it may not, and the GPUs for sure, but it may not be long till the system design is just chunk a heat sink on everything and run it through an internal loop and be gone with it. I don't know if that'll solve all the problems, but that's part of it, right? Or probably.
That liquid cooling technology is just amazing.
Yeah, these HPC system designs that I keep coming back to Lenovo because I think they're just doing such a great job there, are absolutely amazing. A lot of copper in there, but I mean it's just super efficient. And I think the HPC guys will be the first to adopt any new technology that helps them achieve their research mission or whatever it is.
Sure.
But the enterprise has been a little bit more afraid of the notion of water in the data center.
I would think so. Yeah.
I had a coffee in the data center with Kevin the other day, and I spilled it a little bit. We both kind of looked at each other to decide.
Yeah, I've ruined a laptop in the past with a little water spill.
If any damage was done. Thankfully, none. But yeah, I mean, I think that's going to be the next thing to help deal with some of these thermal challenges.
When I mentioned connectors, Brian, one other thing I want to mention is PCI Express cables. We've created a new initiative now to try to come up with a standard PCI Express cable to support the higher bandwidth, the 5.0 and the 6.0 solutions. So we have formed a sort of a new work group and a new initiative to target PCI Express cables because we want to make sure that they're robust enough and sturdy enough to support the 5.0 and 6.0 solutions, and we can come up with something that maybe, because there's a lot of different solutions out in the industry, something that we can maybe try to standardize and get some adoption over.
Are there any new length challenges or quality challenges specific to the 6 spec?
Of course. It's just harder and harder. It's like
what's the servers going to have to get shorter?
Well, retimers or the Mectron technologies, there's just you gotta know what you're doing. You have to be. I like the word I use, precise. You have to understand the technology, and you're going to use a retimer. Are you going to go long, or are you going to use a Mectron technology? Which kind of Mectron technology?
Talk about that a little bit, because we've seen retimers especially in heavy NVMe systems. We just looked at a Supermicro one, but that's another trade-off, because you're going to in that case, you're giving up PCIe slots to run more cabling to the front to those NVMe bays. But so we understand that part of the world. But talk about some of the other options or design considerations there.
Yeah. So the timers, the retimers, switches, right? Because some folks use switches, and switches can sometimes act like a retimer in a sense. You can go to shorter distance, and you can come with a big fat pipe and come out with little pipes. The motherboard technology, and whether or not you use cables, and obviously the connectors, it has to be either some of the connectors that we've established for 6.0, or you need to know what you're doing, or you need to go and use some of the sophisticated cables. Hopefully, some of ours that we're going to standardize for 5.0 and 6.0. So I think those are some of the decision making is the length, obviously, the channel, the Mectron technology, the motherboard technology, the connector or cable. Those are some of your decisions that you have to make, or the retimer switch trade-offs.
So what else are you guys excited about? We talked about storage and interconnect.
The other thing I would mention, sorry, Brian. One of the other things that we're excited about is automotive.
Okay, that's surprising. Why is that?
Yeah, well, we've seen an opportunity early last year, to get more into the automotive space. And I mentioned that 900 member companies as part of our org, and a lot of the new member companies are automotive. We've established an automotive work group. So we believe there's an opportunity, just like we had on the handheld space, to get more adoption and proliferate PCI Express technology in the automotive space. There's a need for speed. There's a need for bandwidth, high data compute because of the instant sensors and the real-time processing that the automotive industry has built with the new safety sensors. So we see that as a huge opportunity for us, and we're investigating what we can do to the technology to make it more automotive friendly and establish ourselves, and increase our adoption in the automotive space. So yeah, we see that as an opportunity for us.
Yeah, you've got a lot going on there, right? Because you've got all the sensors in the car, and not just for the high-end use cases like autonomous driving, where it's probably exponentially more. But you've got all the basic sensors in the car, the cameras now, the rendering, the top view of your car on the screen as you're moving around. I mean, all sorts of things. And then I suppose, depending on the car brand, there's a certain level of data transmission that goes back and forth, but that's
Correct.
over 5G. And while that's great, you still want to be economical with the data you pass. Do you think we'll see things like more analytics in the cars and need more of that high-speed communication? Or what's really driving that?
Yeah, I just think the sensors and the ability to communicate faster and where there's cables and the standardization. So we feel like we can, establish and become more of the standard usage model because we run through cables. We have this huge infrastructure of I mentioned, 30 years. So, we think we can, make inroads there.
Well, yeah, that's interesting. I was going to ask you a little bit about mobile too. I know you've mentioned that a couple of times. What's the latest there?
Well, I don't have all I know is that a lot of the handheld space is using PCI Express. And what happened there historically, because we weren't part of that, I mentioned we got into the being better power friendly. But the other opportunity for us was the fact that the current technology wasn't fast enough. So they needed to change the current technology to run as faster, or they can run our technology as sort of a by one PCIe 1.0 solution, which was fast enough for them. I think that's 500 megabytes per second. So the need for speed enabled us, gave us an opportunity, and we just needed to be more power friendly. And the work group, which is a great set of folks there, came up with the solutions that allowed PCI Express to be more power friendly for the handheld space.
Well, I mean, power friendly throughout has been a pretty consistent message in this conversation, and that's something that we're hearing too. I mean, we run an open air data center here in Cincinnati, which is great this time of the year when it's 19 degrees outside, but less great in August when it's humid and 90 something. And it's not ideal, but we do get concerned about the power consumption, and less power, less heat, better operations in these data centers. And as we look at things like edge IoT or all these other edge analytics use cases where there's so much more happening in these boxes, to optimize data footprint, to do more analytics at the edge so there's not so much data pushed over the wire. The heat and energy consumption, we've talked about it a couple times, is going to be pretty important. So anything you can do there from a flexibility to be more efficient, but also let system designers use your lanes in the most efficient way, I think is pretty strong.
Yeah, like I mentioned, we have made some more changes in the 6.0, and you do have the option to go less lanes with the higher speed.
Yeah.
So maybe that will address some of the concerns. But yeah, there's only so much we can do. Or now we're running 64 gig per second, so it's fast.
So with this flexibility, when we saw the move from Gen 3 to 4, and I'm talking both server and client space, it was relatively smooth, a little bumpy at first because we had some split lane scenarios, but then pretty quickly everything was 4, and just every slot was a 4 slot. And now moving on to 5, on the client side, we're seeing a little bit of diversion there, where like on these Z690 boards where there'll be, one M.2 gets 2 lanes and 2 PCIe slots get 4 or something, right? Where there's
Sure.
some derivation, and you've got to consult the manual to see, okay, where are the lanes? Do I have the right thing to go with this? I'm not sure what it's going to look like yet on the server side, but I worry a little bit about that if we start up with a bunch of split lane scenarios with 4 to 5 or 5 to 6. Do you worry about that at all from a branding standpoint?
I'm not worried about it because we're in the standard business, but not everybody's going to need the 6.0 speed. So, maybe you have only a couple of slots, and like I said, it's going to retire. It's going to require some cost associated with the motherboard technology. So, maybe it does make sense to have one high speed 6.0 solution, and some 5.0, and a couple 4.0. It depends, but I can see it being a mixture because you want to get a return on investment. So, but if you're not going to get a return on investment, do you really want to have that cost associated with it? But 6.0 is not free. Like I said, you have to be precise, and you have to make the investment in the technology that you're going to use, or your design point, whether you need a retimer where you didn't necessarily in the past need a retimer. So it's up to the member companies to make that decision. But yeah, nothing's free.
So is this increased precision requirement in 6 something that's going to be iterative each time, that as we go to 7, 8, 9, 10, that it keeps getting harder?
Sure. This was not easy. What we've accomplished, Brian, is a huge. I can't short sell it. It's 2.5, and not only did we achieve 6.0, but we achieved it 2.5 years after 5.0. So the timing was pretty awesome. It's quite the accomplishment to be able to pull this off and have all the legacy and the flow control unit that the work group came up with, PAM4. It was a sort of revolutionary step in our history.
So when will you start Gen 7? Will you gather some data from these plug fests and let these guys get out there a little bit, or have you already gotten along with that?
We'll probably rest for a couple weeks, and always want to be ahead of the curve. So it's never too early to start looking at the future, and give everybody some visibility on choices and whatnot. So maybe by June we can we have some clarity.
So is there any threat to the PCIe group? Is there some other technology that may ultimately supplant what you're doing here?
I don't think so. Do you think there is, or? I'm sleeping well, so I wasn't sure.
You're waist deep in this thing. I like to consume the tech and put it to work. You're probably, I mean, you said 12 to 18 months. I mean, really, you're about 2.5 years ahead in terms of defining the spec to us seeing shipping product. So, you would know better. I'm just curious how many
we're
more generations you have.
We have the high membership. Our revenue from an organization is all-time high. We just released 6.0 in 2.5 years. A lot of folks when we had the announcements 2.5 years ago, a lot of folks were a little bit more apprehensive, or not sure that we could pull it off. So no, we're doing well, and sleeping well.
Well, good. Well, I'll look you up in another 2.5 years. We can talk about Gen 7.
Well, maybe we'll have an announcement in June, or we'll give you an updates as they come along.
Yeah, and in the show notes we'll link to that infographic. I think that's a neat little visual for people to check out.
Yeah.
Where else can people go if they want to learn more about what you guys are doing?
Well, we have these great YouTube videos on PCI 6.0, Brian. Okay. If you just Google 6.0 on YouTube, they're free. They go into a little bit more technical level of details on some of the things that the work group came up with. So yeah, I welcome anybody who wants more information or more technical information. They're out there.
All right. I will link to those, and for all those system designers and application guys, I mean, they're so hungry for what 5 is going to bring. Just the thought of what 6 can effectively double up on is pretty amazing. And by the time you get your PS, what are we on, 5, 6, maybe PS7 will have Gen 6 SSDs in it, and that thing will load your I don't know, Call of Duty 3000 that much faster. So you'll be off and running. Well, this is great, Al. Thanks for taking the time and giving us the update on what you guys have been up to over at PCIe. We appreciate it.
Oh, thank you so much, Brian.